let's try. So let's go to the average tab now. The average tab is where I define which of my conditions do I want to average. By default, all the conditions will be averaged, and there will be no constraint to them. But I could, for example, say I want to do a comparison between even and odd matches. Then I could add this to the list, and I could see that now I'm going to do an even and odd, or I could do first half, second half to see if there's any changes in the response during the stimulation. But yeah, for the moment, I'm just going to work with all, so no constraints. All conditions will be used. I'm going to run it over the whole data set and press average. Yeah, and now BESA has detected that I've got my artifact correction on, and the software doesn't really like it, so it gives you a warning because it may distort the brain topographies and yeah, etc. But I've already told you this is just something I want to now show for the demonstration purposes, so I'm gonna process without the artifact correction. Okay, I'm gonna now not use the artifact correction, but I'm going to anyway use these data set as I have now scanned them. So let's try this. And again, I'm going to add an S1F minus test to the data so that I don't overwrite any previous results. And then I get asked about my segments that I want to write. So 60 decibels, 70 decibels. So by default, it'll just use the condition name as my segment comment. This is fine. I'll just say stop asking. And now I get directly a view of my average segments of the different conditions from 60 decibel to 100 and then low, high, and all. And I also get a top viewer. So the top viewer opens up and shows me the whole topography from the top. Okay. You can do several things with the top viewer. One thing is you can overlay conditions. So for example, if I go to the low and to the high, I can see these conditions, and I can also overplot them using the control key, and pressing them I can see overplots of different conditions. I can change the colors in the options. For example, color for low is now this dark green. I could change it to pink, then it'll look like this. Yeah, and one thing I want to show you is that if I click on the 60 decibel and now set a cursor somewhere, it'll show me a map at the right. And if I move to around about 630 milliseconds, I can see that I've got an eye artifact here. Yeah, and this is because I did the artifact correction first. Then I did the artifact scan. The artifact scan thought, oh, the data are corrected. So I don't need to reject these trials. And then I switched the artifact correction off for the averaging. So now the trials that had some artifacts will also be in this average. And this is what I can see here. Right, so that is, of course, not so good. But I can do something about it. For example, what I have got is my artifact topography that I have defined for my artifact correction, and I can load this topography. So I can go to artifact and load. And this will allow me to This is the one I just created. This was automatically written by the software. And I can open this artifact topography, and then it'll correct my data set. So now it says corrected again. And if I now open the top viewer again, so I can do this via right click. I can right click in the 60 decibel and go to top view of data. It's also available from the ERP menu. And I'm back at my 60 decibels. If I now go to my 636 milliseconds, now I can see there's no artifacts anymore. So I can do my averaging without the artifact correction, and then I can load the artifact components afterwards, and then it'll still correct my artifacts even after I have averaged them. So that is one way of doing it. Yeah, this is not a bad way, but I think the best way is not to use artifact correction before averaging, because it's especially for auditory signals, these eye blink topographies are actually correlated with the auditory topographies. So it's very difficult to correct an eye blink without distorting in some way the auditory response. But we'll get to that again on Thursday, and we can see what we can do about it in that session. Okay, okay. One thing that maybe you will notice or maybe not is that we have now got a different montage active here. So because I used my artifact correction, the montage is changed to an average reference. Before it was the original reference. And in the top view, I've also got access to all the montages. So I can change, in this case, it automatically re-referenced to average reference, but I can also do double banana here, etc. Yeah, but let's now stick with the original average reference. And one more thing I wanted to show you about this top view is the view. So you can also change the viewing epoch. So if you think my 300 to 1000 is too long, you can also reduce the viewing epoch, assign it to everything, and then you get a shorter epoch in the top viewer. So top viewer is quite flexible like that. Yeah, and now we can right click and zoom, for example, this channel. And I want to find the peaks in this channel. So let me go over this main activity in the FZ channel, right click and find and mark peak. Now I get a list of first of all, it did find a peak. It searched between the epochs that I chose, between 56 and 152. It found a positive and a negative peak. So the negative peak is the one that I'm mainly interested in. It's at 88 milliseconds. So this is the N100 peak, which is quite early in this subject. And I can also see the amplitudes at the positives and negative peaks for, first of all, my search channel and also all the other channels. It also shows the mean amplitude over the area that I marked and the whole area under the graph. Yeah, so one interesting thing is that FZ is not actually the channel with the highest signal, so that was at the FC2, but because FZ was my search channel, the peak will be marked in that channel here. So if I press OK here, then I can see that it'll now mark this peak within N88, so the label contains the latency of the peak, and I can also see when I unzoom again. Yeah, I could I could save, for example, this as an EPS file or as a picture. I've got picture preferences to draw buttons or not. And generally, I can also zoom the display here. I can scale the amplitudes. And as I said, change the colors. The color changes includes the background. So maybe notice that the background is now white. I could change it back to a different color. Okay, this is maybe not a good color. Yeah, so it has many options for customizing this view. And yeah, also the peak results. So if I go back to my peaks, so I can export all these results in an ASCII file. So once I found my peaks, I can do an ASCII export and save it as a text file, and then, for example, load it in Excel or load it in any other text editor to process it further.